Hi, I'm Danny Sell. I'm the lamination manager for Seawind Catamarans. I'd like to take this opportunity to explain to you a little bit about how we build the composite components of our latest model, the Seawind 1370. Firstly, we need to produce a master plug from which to produce our mold. This is cut by a robot on a 5-axis milling machine. This process ensures that our parts match the design perfectly and gives us a high degree of accuracy that we require. From this, we produce a very accurate set of molds. We can get perfect repeat parts every time. These molds are built to our highest standards using only the very best quality of specialist tooling materials such as tooling resin and tooling gel coat and the best boat building practices. Once the molds were delivered to our factory, we carefully maneuvered them into position and we set about leveling everything ready for producing the first parts. The lamination process for the 1370, like all of our Seawind hulls and decks, is vacuum assisted resin infusion. This means that all the fibres are vacuum consolidated into the mould before the resin is introduced to the fibres by means of a vacuum, which gives us a thinner laminate using less resin and is therefore stronger and lighter product. Our first job, like most of our glass boats, is to gel coat and tie layer the mould, which we use a high quality marine gel coat and a vinyl ester resin, which gives us a hull with full protection from osmosis. Once this layer has cured and been sanded, we can start loading the glass fibre to make the strong composite laminate. These are applied as a dry fibre in a uniform layer by following our detailed engineering drawings and are temporarily held in place by spray adhesive. There will also be several additional layers placed in the strategic areas for extra strength, in particularly heavy air load bearing areas. The Seawind 1370 also has significant carbon fibre reinforcement layers to add strength without weight, and these are also placed in the infusion layer. When the outer skin laminate is in place, we'll start applying the foam core, and this gives us superior strength and stiffness to the hull and greatly reduces the amount of layers and fibres needed to achieve the same result. Our foam kits are pre-cut by CNC machines, so in future we receive the foam ready to load straight into the hull, saving us a lot of time and waste, and greatly improves our cycle time so we can produce the hulls faster. Our core foam also acts as a flow medium for the resin to pass through during the infusion process. Once the core is complete, we'll then add the final layers for the inner skin and any other additional strength patches and carbon beams. So now that our laminates are complete, we can start the preparation for the infusion consumables. These will help the resin travel through the fibres and ensure an even controlled flow. Mesh allows the resin to pass over the surface and soak into the core where it can travel along the channels and wet out the fibres. An infusion strategy is made before the start and is modelled to show where the resin is needed to flow in order to wet out all the fibres evenly, no matter how many layers are present in that area. We use a high aspect mesh for the resin feed lines where we want to introduce the resin to the laminates. After the consumables are in place, we need to place a vacuum bag over the entire hull surface and secure around the perimeter with a sealant tape to make it airtight. Then we can turn on the vacuum pump and remove all of the air. This is our most important step of infusion because any air leaks can stop the resin from travelling into the fibres, and the vacuum helps with several things. It secures the laminates in place, compresses the fibres to their tightest bundles, being given a consistent high fibre to resin ratio. It removes any unwanted air voids, and it also helps to boil off any humidity that is trapped in the laminate. Once the vacuum bag is secure and the vacuum test is completed, we go ahead and we attach all the resin feed lines to the T-connectors in the high aspect channels. Each feed line is then marked with an identity and run back to the arc position where the resin bucket will be. This part is crucial to ensuring that we open the valves at the correct sequence, and each one must be absolutely airtight. During the vacuum bag stage, another team will prepare the vinyl ester infusion resin and the catalyst. We make sure that the correct amount of catalyst and resin is weighed out and ready for the mixing team, and that everything is triple checked to make sure there's assurance of this vital stage. Once everything is complete, there's a quick meeting to make sure everybody knows their position and their role before we carefully mix the first batches and we fill the resin baths. Following our infusion strategy, we open the valves one at a time, and the vacuum draws the resin into our fibres and core. The resin will travel along the path of least resistance and flows along the mesh. The grooves and perforations in the foam then channel the resin in the right direction towards our perimeter vacuums. As each area fills with resin, we'll close the valve and open the next one until the entire boat has been fully impregnated with resin. This process takes about 1 hour to complete and will then remain under vacuum overnight. The next day we can come, remove the bag and the consumables to reveal the completed hull. So I hope that helps give you a small insight into how we build our boats here at Seawind Catamarans.